Good morning and welcome to my class. I'm Miss Vandana Gupta, Assistant Professor of Mathematics. So, as you know that we have started with functions, derivatives, and their applications, which is the unit 1 of section 1 mathematics. So, in that applications of derivatives, we have seen the how to apply derivative to find out the marginal cost, marginal revenue, elasticity of demand, and in the last lecture we started with maxima minima. So let me quickly revise how to find out the maximum or minimum value of a given function. See, maxima and minima, they are also called as extreme values, or such problems are also called as optimization problems. To find the optimum value, optimum is either maximum or minimum value by using the derivatives. This is a very useful application of derivative. Okay, so I had given you the step-by-step method to find out the maximum or minimum value of a function. Let me revise it quickly. So whatever function you are having and you want to calculate the maximum or minimum value for that function, for example, we have got the function y equal to fx. First of all, what is the step one? What we have to do? We have to find out the first order derivative of y. Find dy by dx. Okay. In step 2, what we do, we find the solution of the equation, find the solution of dy by dx equal to 0. Now, this equation may have one solution or it may have more than one solution. It depends upon what type of equation you get here. If it's a linear equation like this, then there will be only one solution. If it's a quadratic equation like this, you may say like this, then you may have two solutions of the equation. So this is called a quadratic equation. So it depends upon the equation, what type of equation you are going to get here. So I hope you have understood the second step. First step, take the first order derivative. In the second step, equate that first order derivative to 0. You will get an equation and you have to solve that equation. So suppose that let x is equal to a be the solution of this equation. Be the solution. Okay. Solution of dy by dx equal to 0. Then we move for the third step. The third step is the most important step, which will decide whether your second order, whether your function has maximum or minimum value at the given point. I mean, the maxima and minima will be attained at this point. So at this point, whether the function has maximum or minimum, that will be decided by the third step. So what is the third step? In the third step, we find the second order derivative of y. At which point? At the point x is equal to a, which we have got here as a solution. Okay. Now, if this second order derivative of y at x is equal to a, if it is positive, we don't have to see the value of this. We only have to see the sign. If it is positive, then the function y equal to fx has minimum at x is equal to a. If the second order derivative is positive, then the function will have minimum value at the point x equal to a. And what is that minimum value? And the minimum value is given by f of a. Yes, you will be given the function y equal to f of x. You have now obtain that this function attains the minimum value at x is equal to a. So you put in this, wherever there is x, put x equal to a. So that will give you the minimum value. Now, if the second order derivative at x equal to a is negative, third step, if the second order derivative of y at the point x is equal to a is negative, then the function will have then the function y equal to fx has maximum value at x is equal to a. And how will you give that maximum value? And the maximum value is given by the maximum value of f is given by f at the point e. Means in this equation of the, I mean in the expression for f of x, put x is equal to a. So you will get the maximum value of the function. Okay. Now let us summarize everything and write. So what you have to remember is, for maxima minima, what you have to remember is a function y equal to fx to have maximum or minimum value at x is equal to a. These are the following two conditions for a function. So to summarize, I'm writing, for a function y equal to fx to have a maximum or minimum value, or minimum value at the point x is equal to a, what are the conditions? The first condition is, at that point the derivative of the function should be 0. That is what we have seen in the first step. What is this point x equal to a? It is the solution of this equation, no? dy by dx equal to 0. That means at that point the first order derivative should be 0. So if f dash of a is equal to 0 and equal to 0 and the second order derivative should be negative, then f will have, I will take first positive one, and f dash of a is greater than 0, is positive. Let me write down explicitly that is positive. Then f has a maximum at x is equal to a. Maximum at x is equal to. And second one, if f dash of a is 0 and f double dash of a is negative, then f has a minimum value, at x is equal to a. Okay. So for a function to have maximum or minimum value at a point, these are the two things. If f dash of a, but the first order derivative should be 0 at that point, and the second order derivative, if it is positive, then the function will have maximum. And if it is negative, the function will have minimum. So remember this. These are very, very important. Very important. Okay. I'm writing here very important. Okay. Now let us solve the problems. So what we will do, as you are commerce students, so let me take the problems related to commerce. So you know that in any organization, the aim is to always minimize the cost and maximize the profit, correct? So we will see uh, how to maximize or how to find out the maximum profit. Okay, so let me take one example. I think yesterday we have taken a problem where we have minimized the cost. Today I'm taking the problem where we are going to maximize the profit. So the total cost function of a commodity is given by total cost of producing X units. X articles you can say is given by C is equal to 20 plus 4x. Suppose this is the cost function, okay? And the total revenue function revenue from X articles is given by is when you revenue depends upon the demand, correct? Is given by, so if X items are sold, what is the revenue obtained? That is given by R equal to 30x minus x square. 30x minus x square. So you are given the cost of manufacturing X units and you are also given the revenue obtained after, I mean, selling X items or when the demand is X. Find the number of articles. Find the number of articles, that is X, find the value of X for which profit is maximum. For which profit is maximum. And also find what is the maximum profit. And also find the maximum profit. So find the maximum profit. See, I'm telling you one thing here. See, this problem is, the solution will be bigger. Definitely, such a big question cannot be asked in MCQ. Okay, because you are going to have an MCQ online exam. But if you do not know how to solve this problem, you cannot answer MCQ. Okay, even though the whole problem will not come, but something from the steps can come to test your knowledge. So you have to know how to solve these problems, even though it will not come in the exam. But if you have not understood this now, then you cannot answer the MCQs. Okay, so look at the step-by-step procedure carefully. In this question, what is given to you? The cost of manufacturing X number of items, that is given to you as C equal to 20 plus 4X. And the revenue obtained after you have sold out or X number of items, this is R equal to 30X minus X square. What is asked to you? Find the number of units or number of articles for which profit is maximum. Means how many items should be manufactured or produced and sold to get the maximum profit. And what is that maximum profit? That also you have to find out. So the very first thing is you must know what is the profit. Unless you know what is the profit, you cannot proceed further. So we have to first find out what is profit. As you know that the profit function is given by, I mean, it is denoted by capital P. I mentioned that before also. Whenever I'm using the letter small p, that indicates price. And whenever I'm using the capital letter P, it indicates the profit. So how you give the profit P? Profit is what? Revenue minus cost. How much revenue is obtained after selling the items? From that, you take out the cost of your manufacturing. What remains is the profit. So you know that profit is revenue minus cost. That is P is equal to R minus C. Okay. So such thing can be asked in MCQ. R is this much, C is this much, write a formula for profit. So you must know all these things. Okay, even though the whole question will not like it, in part it can be asked. Okay, so let us find out the expression for profit. It is revenue minus cost. Now revenue is given to you here. How much the revenue given to you? 30x minus x square. So I will put in place of R, I will put 30x minus x square. Minus C is the cost. Look at here, the cost is 20 plus 4x. The cost is containing more than one term, so I have to use the bracket. See, the bracket plays a very important role in mathematics. It's not just like that the brackets are introduced. There is a lot of meaning to the bracket. So because my cost is just not if one term, it contains two terms, so I have to put a bracket. Even R here also you can put, but for the first bracket, even though you don't put, nothing is going to, it will remain the same. Now you have to solve this. So out of this bracket there is no symbol, means it is plus, so this bracket will remain as it is. If outside the bracket there is a minus sign, what happens? The sign of every term in the bracket changes because you are multiplying by minus, right? So 20 sign is plus, it will become minus. So minus 20 minus 4x. Because of this sign will become minus, and even this plus sign will also become minus. Many students, they make this mistake. They don't put a bracket here. And so they take this 4x with plus sign. Okay, see, if you don't put a bracket, you will write like this, minus C. C is 20 plus 4x. So this 4x will remain with plus sign, and that will give you a wrong answer. So always remember that whenever there is more than one term, you always use the bracket to avoid the mistakes, okay, in the calculation. Okay, now what you have to do? We have to simplify this. So it is, first of all, I will write down the term of x square. So it is minus x square. Along with the sign you have to write. So minus x square, and there is only one term of minus x of x square. So that is minus x. 30x and 4x. Both the terms contains x. So 30x minus 4x will give me plus 26x. And then the term minus 20. See, when you are adding, when in algebra or in mathematics, you add or subtract like terms. Like terms means x will be added and subtracted with x only. You cannot add 30x and x squared together and write 31 or 29x squared. This x term will go along with x term only. So this 30x minus 4x will give you 20 plus 26 because 30 is with plus. And this minus x square, and finally this minus 20. So I have got the expression for profit. So this is my formula for profit, correct? Now I was not given the profit directly. I have calculated profit by R minus C. R and C was given to me. Now I have to maximize this profit. I have to find out the value of X at which this profit is maximum. So I will apply my step-by-step procedure to find out the profit. I will just put it here. So now we have to maximize profit. Now we will maximize profit. Now what is your profit? It is given by minus x square minus x square. What was that? Here it is. So how much we got the profit? Minus x square plus 26x minus 20. Correct? Plus 26x minus 20. So we have to maximize profit P equal to minus x square plus, what was that? Minus x square plus 26x plus 20. Correct? Minus 20. R minus C, no? Is minus 20. So we have to maximize this. So what will we do to maximize this? First of all, we have to take its first order derivative. This is the first step, correct? Step 1. So what is the first order derivative of this P? P is minus x square plus 26x minus 20. Take its derivative. So it is equal to derivative of minus x square plus derivative of 26x minus derivative of 20. Correct? What is derivative of minus x square? Minus is a constant. You will take, minus 1 is a constant. You will take that out. So it is derivative of x square plus 26 is taken out into derivative of x minus derivative of 20 is 0 because 20 is a constant, and derivative of x square is 2x. So minus 2x plus 26, derivative of x is 1. So you will get minus 2x plus 26. So this is your very first step over. First step is over. Okay. First, in the first step, you have to take the derivative of this profit. So this is coming as minus 2x plus 26. In the second step, what we do? We solve the equation dp by dx equal to 0. Here our function is profit function. In the step-by-step method, I have taken y. Okay. So y is replaced by p here. Second step. Solve the equation dp by dx equal to 0. P is the profit. Okay. So what is dp by dx we got? Minus 2x plus 26. So minus 2x plus 26. This is equal to 0. So what will be the value of x? Therefore, minus 2x we will shift to the other side. So we will get 26 equal to 2x. So what is the value of x? 26 divided by 2, that is 30. Okay, so we got the value of x as 30. Now what we have to do in the third step? We have to find out the second order. Now here you are getting only one value of x because this equation was a linear equation. If it is quadratic, you will get two values. Okay, so here only one value. Find the third step, second order derivative. So first of all, find out the second order derivative of p, not y. Second order derivative of. So what is second order derivative? How we define second order derivative? It is the derivative of the first order, correct? So it is the derivative of the first order. And first order is minus 2x plus 26. Okay. This is your first order derivative of p. So this is equal to derivative of minus 2x plus derivative of 26. What is derivative of minus 2x? Minus 2 is a constant. It will minus 2 into derivative of x plus derivative of 26 is 0. So you will get minus 2, correct? Minus 2. Derivative of x is 1. So minus 2. So look at here, the second order derivative is coming as positive. Is negative. What happens when the second order derivative is negative? Therefore, P has maximum. At which point? At x is equal to 30. This point. Okay. Because the second order derivative is coming negative, the function has maximum value at x is equal to 30. Okay. And how will you find out the maximum profit? And the maximum profit is given by, and the maximum profit is given by, profit at x is equal to 30. So what was the formula of profit we got? This was the formula for profit we got, right? Minus x squared plus 26x minus 20. Look at here. This was our profit. Minus x squared plus 26x minus 20. Minus x squared plus 26x minus 20. So in this formula, put x is equal to 13. So 13 square plus 26 into 13 minus 20. So 13 square is 169, and 26 into 13, how much? Use the calculator to solve this. So you will get minus 169. 26 multiplied by 13 is equal to 338. 338 minus 30. Now you have to simplify this. So you are getting 139. Okay. So the maximum profit is 139. And it is when you are getting maximum profit, when x is 13. That means 13 items you manufacture and 13 items are sold, then you get the maximum profit. Okay. So I hope you have understood this. So this is how we can maximize the profit. Okay. So once again, quickly let me explain you this once again. To maximize the profit, what we did, first of all, we have found out the function profit. What is function profit? Revenue minus cost. Revenue is 30x minus x square. Cost is 20 plus 4x. Because they contain more than one term, put the bracket. Then if before the bracket there is a minus sign, the sign of each term of the bracket will change. So this will become minus 20, this will become minus 4x. And then when you simplify, it will become minus x square. 30x minus 4x will give you plus 26x, and then minus 20. So now we have got the expression for profit. So you have to maximize that profit. So what we do in the next one, we have to maximize the profit. So we take this profit, we go step by step. Okay, first step is find the derivative of profit. So derivative of profit P means minus x square plus 26x minus 20. So derivative of minus x square plus derivative of 26x minus derivative of 20. That will give you minus 2x plus 26. Okay, so we got the first order derivative. In the second step, we have to equate this to 0 and solve the equation. So we solve the equation dp by dx equal to 0. Minus 2x plus 26 equal to 0. So you get 26 equal to 2x. So x is equal to 30. Then you find out second order derivative. This is coming as minus 2. Derivative of the first order. First order is minus 2x plus 26. So derivative of minus 2x plus derivative of 26. Derivative of minus 2x. So minus 2 is a constant. We are applying the scalar multiplication rule. This one. Derivative of k into u. K is a scalar. So k is taken out. This rule I have applied. Okay, for this. So minus 2 is taken out. So derivative of x. 26 is a constant. So its derivative will be 0. Now derivative of x with respect to x is 1. So you are getting minus 2, which is negative. So the function will have maximum at x equal to 30. If the second order derivative is coming as negative, then the function will have maximum. If it is coming positive, then the function will have minimum. So here it is negative. So profit is maximum when x is equal to 30. So you have got that the profit will be maximum when number of items produced and sold are 30. But how to find out that maximum profit? In the formula of profit, put x is equal to 30. So that is what we did. Put p x is equal to 13 in the formula of profit, and we got 130. Okay, so that's all for today. So we have completed this last maxima and minima also. Now let me give you one small you can say a homework problem so that you can work out on that. Okay, so you solve this problem. Today is a holiday, you can do it. The revenue and total, this is a homework problem, exercise homework. The total cost function C is given by 50 plus 4x. Okay? And the